Central tendency indicates where the center or the middle of the distribution tends to be. Example, you took a test and you got 94. You may have done exceptionally well or maybe not. Perhaps you're really smart or perhaps the test is really easy. And if I just tell you the raw scores, 80, 94, 73, 88, 86, 72, and you still don't really know that much. But if you know that your score is 94 and the class average was 80.5, then you know that you did really well. A measure of central tendency answers the question of whether the scores are generally high or generally low. From the example, if I tell you about my friend who is a basketball player, what do you assume about his height? Based on what you know about basketball players in general, you might assume that his height is above average, because you know that the height of a basketball player is generally high. Another example, if I tell you about my friend who is a horse jockey, you might assume that his height is generally low. These instruments are based on what you already know about what the heights of certain individuals tends to be. You are using a measure of central tendency. Measures of central tendency offer the benefit of simplification. The whole sample of raw data is difficult to understand. A measure of central tendency gives us a single number that represents the entire dataset. Central tendency also has the benefit of prediction. Knowing a measure of central tendency can help us to predict other scores or estimate future needs. And this is true even if the measure of central tendency is not in the actual data set. If I tell you that the average family has 2.3 children, but in our city is projected to grow by 1,000 families in the next 5 years, how many new classroom seats will we need in public schools? Although no family who knows on our town literally has 2.3 children. The average is still very useful for predicting how many children will be entering the school system. Determining which measure of central tendency to use depends upon two things. First, it depends upon the scale of measurement, nominal, ordinal, interval, or ratio. Each scale of measurement has properties that determine how to properly analyze the data. For instance, the mean is typically used with interval or ratio level data. Second, our choice of a measure of central tendency depends on the shape of the distribution. If the distribution is highly skewed, we may choose a specific measure of central tendency. There are three measures of central tendency that we will learn about: the mean, median, and mode.
All of you, I will tell you the meaning of mean or what does mean means. But before I start, let me introduce myself to you. By the way, my name is Maria Altea Joy Labis. So let me start. A number or quantity having a value that is intermediate between other numbers or quantities, especially an arithmetic mean or average. See more at arithmetic mean. Either the second or third term of a proportion of 4 terms in the proportion 23 equal 46. The means are 3 and 4. Compare the extreme. In statistics, an average of a group of numbers or data points with a group of numbers. The mean is obtained by adding them and dividing by the number of numbers in the group. Thus, the mean of 5, 7, and 12 is 8. 24 divided by 3. Compare the median and mode. Thank you.
Mode is defined as the score with the highest frequency, the most frequent score. It is called a nominal statistics in a group data. It is the mean point of the class interval with the highest frequency. Characteristics of the mode. Number 1 is a nominal statistics. Number 2 is an inspection average. Number 3 is the most frequently occurring score. Number 4 is usually occurs near the center of the distribution. Number 5 cannot be obtained by the mathematical operation. Number 6 is the most popular scores. Number 7 is some distribution have more than one popular score. Example of mode is number 7, 3, 4, 7, and 6. The most common number is 7. Kaya ang mode po niya is number 7.
Good morning. My name is Kaisilin Cularina. So today I will be discussing about median. So what is median? Median is a middle number in a sorted ascending or descending list of number that can be more descriptive of that data set than the average. If there is an odd amount of numbers, the median value is the number that is in the middle with the same amount of numbers below and above.
MF by 2 minus CF, open parenthesis CW by FMC. Ibig sabihin naman po ng mission frequency or MF is total frequencies. Ang LBMC is the lower boundaries of median class. Ang FMC, frequency of median class. Ang CW is equal to class width. Ang CF is cumulative frequency. Ang before proceeding the median class. Sa median naman po, example is 7, 3, 4, 1, 7, and 6. Sa median naman po, in-arrange po siya, naging 1, 3, 4, 6, 7, and 7. Ang median po niya is 4 and 6. Tapos yung 4 and 6 ay inad. Kaya naging 4 plus 6 is equal to 10 divide 2.
The range is the difference between the largest and the smallest observation in the data. The prime advantage of this measure of dispersion is that it is easy to calculate. On the other hand, it has a lot of disadvantages. It is very sensitive to outliers and does not use all the observation in the data set. It is more informative to provide the minimum and the maximum values rather providing the range. Example is numbers 5, 6, 7, 8, and 9. 9 minus 5 equals 4. So therefore 4 is the range.
It is the average amount that the value in a data set differ from the mean. It is also the arithmetic division of different items of central tendency. It may be the mean of the median. Central tendency. Number 1. Mean sum of score divided by the number of score. After referred to as the statistical average. Number 2, median. Middle modes number MD 3. Modes frequently according number. Measure of dispersion. What is measure of dispersion? Measure of dispersion. It is to describe the spread of data. It is also a descriptive statistic that describes how similar assets score to each other. Standard deviation. It is the most commonly used measure of dispersion. It is a measure of the spread of data about the mean. It is the square root of the sum of the squared division from the mean divided by the number of the observation. Example of the standard deviation. Measure of dispersion. Sample. Standard deviation. Calculation example. Data x 10, 12, 14, 15, 17, 18, 18, 24 over n equals 8 main, x equals 16, set 10x squared, 10 negative x squared, positive 12 negative x squared, 14 negative x squared, positive 0 positive 24 negative x squared. Then over n negative 1, 10 equivalent the x 16 squared, 12 negative 16 squared, 14 negative 16 squared, positive 0 positive 24 negative 16 squared, and divided by 8 negative 1. This calculate is the measure of the average is 33 130 over 7. The final average is 4.3095. Calculate the standard deviations of the following number shown in the table below: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Compute the mean. X bar equals 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 plus 80 plus 90 plus 100 is equals to 550 divided by 10 is equals to 55. This is main computation is equals to 55.
Measure of depression is the distribution of data described by depression measures. The interquartile range, standard deviation, and variance are among them. The smallest and largest observation are given as the range. This is the most basic measure variation. Measure of depression describe how broadly the data disperse. Some of there are range, interquartile range, standard deviation, and variance. The range includes both of the smallest and greatest observation. The standard deviation is the most extensively used measure of depression. SD is calculated by multiplying the square root of the sum, squared division from the mean by the number of observation. This is the simplest way how to figure out how much variety there is among a measure of depression indicates of scattering of the data.
It explains how data differs from one another and depict their distribution clearly. Interquartile range are lowest and highest, the IQR is the most extensively used measure of depression. SD is calculated by multiplying the square root of the sum, squared division from the mean by the number of observation. This is the simplest way how to figure out how much variety there is among a measure of depression indicates of scattering of the data. It explains how data differs from one another and depict their distribution clearly. Interquartile range are lowest and highest, the IQR. Describe the median 50% of values. Find the median middle values of the lower and higher half of the data. To get the interquartile range, there are the interquartile 1 and interquartile 3. The difference between interquartile 3 and interquartile 1 is the IQR. The interquartile range, also known as the middle 50%, or in this descriptive statistic. This is a measure of statistical depression equal to the difference between 75th and 25th%, or between the upper and lower quartiles, or IQR equals quartiles 3 and quartiles 1. Example of the formula quartiles is given by lower quartile 1 equals n plus equals 1/4. Middle of quartile 2 equals n plus equals 2/4. Upper quartile 3 is n plus equals 3/4. Interquartile range equals quartile 3 and quartile 1.
Measure of relative precision. Definition are conversion of values, usually standardized test score, to show where a given value stands in relation to other values, the same grouping. The most common example in education is the conversion of the score on standardized tests to show where a given student stand of relation to other students of the same age, grade level, and etc. Converted score are based on the standard division of distance of a raw score from the mean for a normal curves or distribution and a normal distribution. The distance from one SD above the mean to 1. SD below the mean includes approximately 68% of all score, plus 2 to minus 2. SD includes approximately 95% of all score and plus 3 to minus 3. SD includes over 99% all of score.
A quartile is a statistical term that describes a division of observation into 4 defined intervals based on the value of the data and how they compare to the entire set of observation. Quartiles are the value that divided a list of the number into quartile. Like example, 5, 7, 4, 4, 6, 2, 8. Put in the order into 2, 4, 4, 5, 6, 7, 8. The 4 is quartile 1, it's lower, and the 5 quartile is the median, and the other one is 7 is a quartile 3, it's very upper, and the result is quartile 1 equal to 4, quartile 2 equal to 5 is the median, and quartile 3 equal to 7. Thank you.
Good day everyone. So today I will discuss the assigned topic, the most commonly measures of positions. And we also have three types of understanding positions. First is percentiles, second is quartiles, and the third is standard scores or Z-scores. So I will discuss the percentiles. Percentiles, statisticians often talk about the positions of value relative to other value in a set of observations. Assumes that the elements in a data sets of rank order from the smallest to the largest. And we also have the value that divide a rank order's set of elements into 100 equals part are also called percentiles. We have also an example of percentiles. So the 20th percentiles is the value below which 20% of the observations may be found. The term of percentiles and the relative terms percentiles ranks are often used the reporting scores from the referred test. We also have percentiles formulas. Percentiles equals numbers of the value below x slash totals numbers of the value times 100. P equals m slash n times 100. P stands for percentiles and stands for numbers of value in the data sets. And small letters is the ordinal rank for the given value or value below the numbers or percentiles numbers value times 100. So step 1 formulas. Step 1, arrange the data sets in the ascending order. Step 2, count the numbers of value in the data sets and represent it as R. Step 3, calculate the value of 9 over 100. Step 4, stand for multiply Q percent by R. Step 5, if the answer is not a whole number, then rounding the numbers is required. If it is a whole numbers, continue to the next step. And the last step is count the value in the data set, find the mean, and the next number. The answer will be after percentiles. Proceed to deciles. Deciles are measures of positions calculate on a set of data the value that separates contributions into equal parts, where each part contains the same numbers of observations. Deciles is most commonly the same for percentiles. Deciles is a members of the wider family of quartiles. Quartiles is also mean deciles. Deciles are similar to quartiles. Quartiles divides ungroup data into 4 quartiles, quarters or deciles. Data 10 equals parts or etc. Divides rank. It is a quartiles. Data into the equal parts. So we also have D1, D2, D3, D4, D5, D6, D7, D8, D9.
Good day everyone. In this video lesson, we are going to discuss measures of relative position, especially z-scores. Z-scores measure the distance between an observation and the mean, measured in units of standard deviation. So, we are going to use this formula, value minus mean all over standard deviation. For population data, we're using this formula. So, this x minus the mean, so we're going to use these symbols, the mu symbols, over the standard deviation. And for example data, we're going to use this formula. So, x minus the mean over the standard deviation. So, if the z-scores is positive, okay, remember, the positive scores is above the mean. If the z-scores is 0, the scores is the same as the mean. If the z-scores is negative, the score is below the mean. For example, an IQ test has a mean of 105 and a standard deviation of 20. Find the corresponding z-scores for each IQ. First, the z-scores is 88, so using the formula, value minus the mean over the standard deviations, so substitute lang natin, so that is divided by 88 minus 105 divided by 20, so the answer is negative 0.5. Since the value of r z-scores is negative, so therefore 88 is below the mean. Okay, next, 122. Okay, if our scores is 122, same the process, using the formula we substitute. 122 minus 105, so 122 minus 105 by 20, the answer is 0.85. And the 0.85 is positive, therefore 122 is above the mean. Next, 110, same process using the formula, we substitute 110 minus the 105 divided by 20. So 110 minus 105 divided by 20, that is 0.25. And the 0.25 is positive numbers, therefore meaning our score is positive, therefore 110 is above the mean. Next, which of the following exam grade has a better relative position? A grade of 43 on an algebra test with mean 40 and standard deviation is 3, or a grade of 75 on geometry with mean 72 and standard deviation of 5. So, in order to find which of the following exam grade has a better relative position, we need to find out the z-scores of the two tests. Okay, first, the algebra test with the scores of 40 with a grade of 43. So, let's find out the value of z-scores. So, 43 minus 40 divided by 3, the answer is 1. So, in algebra test, the z-score is 1. Next, For geometry test with a score with a grade of 73, so that is what after that a grade of 75 minus 72 divided by 5, and that is 0.6. So what do you think? So which of the following grade has a better relative position? Since in your algebra test the z-score is 1, and for geometry grade, no, that is algebra, yeah. For geometry, that is 0.6. What do you think? Okay, since the z-scores for the algebra test is larger, the position in the algebra test is higher than the position in geometry test.